I'm with Imagino. Imagino is a venture-backed incubator funded by a family office. We're headquartered in Bellevue, Washington, and we have additional facilities at the University of Washington and in Boise, Idaho. We focus on ideas in aerospace, energy, healthcare, and water science. Today, I want to speak a bit on the changing needs of space. Next slide. The demand for space launch systems is increasing for both commercial and military applications. Aside from communications, satellites are needed for AI, data gathering, incident monitoring, and global security. In satellite launches alone, there's a predicted four-fold increase from 2019 through 2028 when compared to the preceding 9 years. With space tourism and eventual commercial space travel added, the number of launches will continue to grow year over year. Next slide. In rocketry, the mass of the payload is limited by the mass of the vehicle and propellant. The payload makes up a small fraction of the launch mass. The remaining mass is the vehicle and its propellant. When generating lift by combustion, the largest single contributor to mass is the required oxidizer. Limitations on payload impact all uses of space as they burden the launch cost. Next slide. Our solution to these constraints is to develop an efficient propellant and propulsion system that uses no oxidizer, taking up a fraction of the volume and mass of what current propellants require. This solution can be integrated into existing rockets, retrofitting rather than reinventing. This allows an increase in payload mass that can be placed into orbit to meet the needs of an expanding industry. Next slide, please. Bihydrogen propellant is based on a novel use of hydrogen, which replaces both the fuel and oxidizer. The same basic components of the rocket remain relatively unchanged, yet the performance of the lift system can be increased by over 10-fold. Next slide, please. The generation of bihydrogen propellant begins with molecular hydrogen, known as H2, which consists of two hydrogen atoms bonded together. Bihydrogen works through the separation and sequestration of these two atoms, followed by a rebonding and energy release. Creating the bihydrogen propellant by separating the hydrogen molecule requires a considerable amount of energy to be added, as the two atoms are tightly bonded to one another. This amount of energy is recovered once the atoms are recombined. Next slide, please. The two atoms of molecular hydrogen exhibit different quantum spin states, effectively two separate species of hydrogen. Once separated, these unique spin state hydrogen atoms exhibit an opposing reaction when exposed to a magnetic gradient. Each is deflected in a different direction and can be sequestered and stored in separate vessels. The energy used to separate the molecule is then recovered by allowing the two species to recombine. Next slide, please. This recombination and release of the stored energy is used to generate thrust. Bihydrogen is 5.4 times more efficient than oxyhydrogen combustion. Some additional advantages are the elimination of a source of ignition and a simple method of throttling the thrust output. Next slide, please. Bihydrogen propellant and propulsion can increase the payload lift capabilities by a considerable factor. This increases the mass of the payload, reduces launch costs, and increases the number of payloads which the rocket can deliver. Using the Delta IV Heavy as an example, the fractional mass of the payload is 3.5% when using oxyhydrogen as a combustion propellant, compared to near 53% when using bihydrogen as an energy carrier, allowing 15 times more payload mass. Next slide, please. So where are we with this technology? We're currently at the validation stage. We're seeking grants and/or convertible notes, as well as strategic partners to gain access to an appropriate facility with a vacuum chamber and cryogenic systems. We're also seeking to hire additional personnel in the vein of a nuclear chemist, cryogenic engineer, and mechanical engineer, as well as outside contractors. We estimate $1.5 million in personnel, materials, and equipment costs. Additional facility costs are to be determined. Next slide, please. Thank you for your time. The team and I are available for questions.
Awesome. Thank you, Kevin. Open up the floor. Any questions for Kevin?
Yeah, I can ask one. What is the runway time that you guys are seeing from basically partnership to being able to start producing?
Well, as I mentioned, we're really at the validation stage at this point. We're fairly early in this technology. We do have IP protection for it in place, but we're now, as I said, we're a venture-backed fund, and we're looking to expand, and particularly expand with strategic partners, ones that do have lift systems. We're primarily a B2B licensing model is our plan, though there is a potential that we could become a launch system at some stage. As for the time, the runway we're looking for right now is between 18 and 24 months.